Have you ever wondered how an AI actually learns to be smart? Not just following rules, but genuinely learning from experience. Well, today we're going to pull back the curtain on one of the coolest ideas in AI, called action value methods. And I promise, by the end of this, it's going to feel way more simple than it sounds.
So here's our game plan. We're going to start with the big question. Why do we even need this stuff? Then we'll use a really simple analogy, a food cart maze, to make it all click. After that, we'll build our AI's brain, which we'll call its value menu, see how it learns, and then wrap it all up with the one key takeaway you should remember.
All right, let's dive right in. First things first, the fundamental why.
I mean, think about it. This is the challenge for any learning machine. Imagine you drop an AI into a totally new world, a video game, a robot simulation, whatever. It has a goal, but it starts out knowing absolutely nothing. It doesn't know the rules, it doesn't know what's a good move, what's a bad move. So how on earth does it figure out the best thing to do?
This is the whole idea behind a field called reinforcement learning. You've got this agent, or learner, and its entire job is to learn what to do through pure trial and error. Its only mission in life is to take actions that get it the most reward possible in the long run.
Now, to make this really intuitive, let's just forget the jargon for a minute. Let's ground this whole thing in a simple analogy that we're going to stick with for the rest of this explainer.
Picture this. You are standing smack dab in the middle of a giant maze, and hidden all around this maze are different food carts. Some have amazing 5-star tacos. Others, well, they have some pretty sad 1-star sandwiches. Your goal is simple. Find the path to the most delicious food.
This little food cart challenge is a perfect mirror of what our AI agent is up against. The goal is to maximize that tastiness reward. The problem? You start with no map, no clues, nothing. The only way to figure it out is to just start walking around, to learn by doing.
So, how would you actually solve this? You'd probably start building a mental map, right? Well, in AI, we do basically the same thing. We build what I like to call a value menu, a guide that helps our agent decide what to do. Let's break down how it's made.
Okay, first up, we have the idea of a state. It sounds technical, but it's just a fancy way of asking, where am I right now? In our maze, a state is just your location. Maybe you're at intersection A, or that spot next to the weird-looking statue. It's how the agent knows its current situation.
Now, from any given state, the agent has a bunch of actions it can take. These are just the moves it's allowed to make. So if you're at intersection A, your actions might be go north, go south, go east, or go west. It's the list of choices you have at that exact moment.
And this brings us to the secret sauce, the big idea. It's called an action value, or sometimes a Q value. This is the predicted tastiness score for taking a specific action from a specific state. See the difference? It's not about how good a location is, it's about how good the move itself is. Going north from intersection A gets its very own score. This table you're looking at? This is our value menu, or a Q table, as it's officially called. This is the agent's brain at the very beginning. You can see every location, or state, and every possible action. And notice what all the scores are? 0. That's because our agent is a total rookie. It has 0 experience, so it assumes every move is worth nothing. Okay, so how does this totally blank menu turn into a useful guide? Well, it all happens through a simple, repetitive cycle that we'll call the learning loop. It's really just a simple 4-step dance. 1, the agent checks its menu for its current spot. 2, it picks a path to try. 3, it gets a reward. Maybe it finds that amazing taco cart and gets a +5 tastiness score. And 4, and this is the magic part, it goes back and updates its menu, changing the score for the specific choice it just made. Now, the math behind the update is actually super intuitive. You can think of it like this. The new score is just the old score, plus a little nudge in the right direction. And that nudge is based on the difference between the reward you actually got and what you expected to get. It's all about correcting your own expectations based on reality.
So let's make that real. Our agent is at intersection A. It checks the menu, and the score for go north is 0. It expects nothing, but it decides to try it anyway, and bam, it finds a +5 taco reward. Now it's time to update the menu.
And here it is, right in action. The tastiness score for the move go north from intersection A isn't 0 anymore. It's been updated to a positive number. From just one single experience, the agent has learned that this specific move, it might be a pretty good one.
Now, just imagine our agent doing this over and over and over again. Thousands, maybe millions of times. It just wanders the maze, trying things, getting rewards, and constantly tweaking its value menu. And slowly but surely, all those zeros get replaced with useful, reliable scores that actually predict how good each move is.
Okay, we've gone through all the pieces, and it really all boils down to one simple, powerful idea. So if you remember just one thing from all of this, let it be this.
Action value methods are all about building a cheat sheet. That's it. A giant guide, our value menu, that doesn't just rate places, it rates every single move you can make from every single situation. And once that cheat sheet is filled out, making the best decision is as easy as just looking up the move with the highest score.
This whole table idea works perfectly for a little maze. But what about a game like chess or Go? The number of possible situations, of states, is astronomical. You could never, ever build a table big enough. So how do we solve those problems? Well, that's when we stop using tables and start using powerful neural networks to estimate the value menu. But that, my friends, is a story for another time.